Hi, today I'm going to give some extended lesson example 17 and 18 from the lecture notes. So what we are going to do is we're going to solve the problem involving the combination of the differentiation rules. If you are ready with it, let us proceed to the example 17. From the example 17, the question is mentions about find the derivative. So when the question is mentioned about derivative, it means that we are going to do something as d dx toward a function cos 5x plus 4. So the notation d dx is represent the derivative of, because this question is not given you y equals to something, it just given you a function here. Okay, so what you are going to do is, if you want to solving this, we have to identify the outer and inner function. So the differentiation will start from outer function, slowly go into the inner function. So for example A, okay, so the outer function is 1, inner function is a linear 5x plus 4. So for the question B, the outer function is 1 and the inner function is a ln x. And the question C, outer function is tangent and the inner function is 1 over 6 pi minus 3x. So come to the last one, the outer function is secant and the inner function is linear 2x plus 3. So how are we going to write the solution? Okay, so looking at this, as we know that when we differentiate cos, you get the negative sign. So you copy back, okay, differentiate cos, you get negative sign, and the function 5x plus 4 exactly the same, and we differentiate the second layer, which is 5x plus 4, where you will obtain just a constant 5. So lastly, you just simplify, you get the answer negative 5 sign in bracket 5x plus 4. So the second one, the inner function is a ln, outer function is a sine. So differentiate sine, you get the cos, okay, and copy back the ln x and you differentiate the ln x. So as we know that differentiate the ln x, we get that is a 1 over x. Okay, so we just rearrange it again, so you get the solution. Okay, so let us proceed to the C. Tangent 1 over 6 pi. So my dear, you have to be careful with it. 1 over 6 pi is a constant number. So don't tell me that it's a 1 over 6 pi power 1 minus 1. No such thing, right? No need to do that. Okay, what you have to do is differentiate the tangent. Okay, and then differentiate the inner function. So you should get different tangent based on the basic is secant square. So after you write the secant square, please write back again the function 1 over 6 pi minus 3x, and we're doing the second differentiation inner function, so you obtain a negative 3. Okay, so lastly, simplify the negative 3 become the final coefficient. Okay, so from here you get the values negative 3, and simplify it, start from the coefficient and then followed by the trigonometry function. So the last one, it will be secant. So differentiate secant, we get secant tangent. So you cannot write secant tangent, you must secant 2x plus 3, tangent 2x plus 3, and differentiate the linear, so you obtain a constant 2 and make it as a coefficient of the result. So that's it, the very simple example 17. Okay, let us move to the example 18. Okay, so example 18, what did you notice from here is the previous example you found that the degree is 1. So now we are given you the degree is more than 1. So we're using the very basic one, which is power 2 and power 3. So how we're going to do it is, again, we need to identify. Now the most outer function, it will become power. Okay, and followed by secant. And then lastly, only the linear function x. So now you become a 3 layers. Okay, so for the question B, the first layer is a power, second layer is a trigonometry sine, and then the third layer is a quadratic x squared plus 1. So same goes to the question C. The first layer is a power 3, second layer is a cotangent, and the third layer is a x. Okay, once you identify already the layer, then we are only starting to do the differentiation. Okay, example 18 is different from the 17 because now you are given y equals 2. So you don't need to write d dx. You can straight away write it as dy dx. Okay, so we look at the first one. Okay, why we can say this? dy dx equal to 2 secant x. So you look back again. Okay, you look back again. Just now we mentioned about the first layer is power, right? So therefore, dy dx equals 2. So we're using the general power rule. So the power 2, you bring it in front. So the exiting power will become secant power 1x. And we differentiate the second layer, which is secant x. So therefore you get 2 secant x. You just copy back. So differentiate secant, we get a secant x, tangent x. And do not forget, we differentiate the third one, coincident, it's just a 1. Okay, the third layer. So lastly, we simplify, you get a 2 secant square x, tangent x. So this is the simplest form. Okay, so this is how we obtain for the question A. For the question B, so dy dx is equals to, so the power 2, and the sign is still copied back with the power 1, and inside is still the same, x squared plus 1. Okay, this is a power rule, and then followed by, we need to differentiate. What you need to differentiate? We need to differentiate sine x squared plus 1. This is the second layer. Okay, so let us continue. For those who already done, okay, I'm write it over here, eh? So it will become 2 sine x squared plus 1. Just copy down it. Differentiate sine, we get a positive cos x squared plus 1. And the third layer is a quadratic, so it will become differentiate x squared plus 1. So lastly, we only can complete the differentiation where it's equivalent to 2 sine x squared plus 1 cos x squared plus 1. So as you know that this one differentiate x squared plus 1, you get a 2x. So can we stop by here? The answer is no, because we need to simplify until you get the coefficient is 4 and then followed by the linear x. Trigonometry, you leave it at the last one. Okay, so we get this easily. So I believe that you are able to do for the question C. Okay, so now we are using the power other than 3. So it means this one will become dy dx equals to 3 cotangent square x. And we are differentiate cotangent x. Don't take the power anymore because now the cotangent is under the 3. Okay, so we just differentiate cotangent x. So this one will become copy back 3 cotangent square x. So as we know that differentiate cotangent, you get the negative cosecant square. Okay, and then because x, just now I already mentioned the x, if you differentiate x, you get 1. So if you didn't write it, also never mind. If you still want to write it, you just write down d dx x. So lastly, simplify, you should get the solution as negative 3 cotangent square x cosecant square x as the final answer for the question C. So it's a very simple question. That's all for the example 17 and 18.